Welcome to the debate. Our subject today is a pretty profound case study in automotive archaeology, really. We're looking at a classic boxy Volvo 245 station wagon. This thing was pulled from the darkness of a dusty anchor garage where it had been locked away, completely neglected for nearly 30 years.
30 years, and now it's undergoing this complete mechanical reawakening. And, the material integrity of this car, its actual structure, its bones, is just astonishing. But at the same time, its operational systems required, profound, immediate intervention simply to function again.
And that incredible dichotomy, that split between the material permanence and the systemic collapse, is exactly where our disagreement has to focus. So the central question we're grappling with, and this comes right out of the material, is this. When a vehicle shows such profound, enduring structural durability after 3 decades of neglect, that quality we often call over-engineered, should its lasting value be rooted in that inherent, almost tank-like quality?
Or is that intrinsic durability ultimately just negated by the immediate practical fragility and the functional obsolescence of its highly specific, dated mechanical systems?
Right. I'm going to hold that the inherent over-engineered quality of the physical structure and its primary components, that's what defines the vehicle's enduring value. The fact that it resisted 30 years of decay is the definitive, measurable proof of a superior design. And that's what justifies this whole extraordinary restoration effort.
And I'm going to maintain that the vehicle's true long-term functional value is, fatally undermined by the fragility and complexity of those specialized, dated mechanical systems that inevitably failed. Structural resilience is basically meaningless if the car can't perform its basic function without demanding expertise that is, frankly, rapidly becoming obsolete. The vehicle's greatest asset, its durability, actually created the conditions for its greatest liability, its systemic obsolescence.
Okay, so let me start by detailing why this Volvo 245 exemplifies a standard of engineering that, I think, deserves our highest regard. Its durability isn't just a legacy, it's empirically verifiable. The restoration documented the attempts to simply get the door open, which had fused shut over the decades. The locksmith, a guy named Mahir Usta, he attempted to use these powerful air pumps to pry the door frame away from the seal. He had to use not 1 but 3 of these industrial air pumps, all applied simultaneously. And the heavy structure of the car, it would not even visibly flex. That right there confirms its reputation as a tula, or a brick. It's a physical statement of permanence.
The structural integrity of the shell is absolutely undeniable. I completely agree that few, if any, modern vehicles could withstand that kind of long-term static pressure without some serious distortion.
But the superior engineering goes deeper than just the body panels. Look at the core components the mechanics found. The engine block is a dokum block, a massive cast iron block. And the mechanics noted, this design offers just a minuscule chance of cracking compared to, the modern thin-wall aluminum designs we see everywhere today. We also saw surviving original Volvo stamped components all through the engine bay, the hoses, the original clamps, and even the V-belt, still bearing the original logo, decades after it was made. This level of material quality across the board, from the chassis to what should be consumables, it demonstrates where the priority lay in this era of manufacturing. The difficulty of the eventual restoration, that simply reflects the demanding standard required to bring a truly durable machine back online after resisting 30 years of deep, deep decay.
I appreciate the emphasis on material resilience. I really do. But I think that view confuses quality with completeness. A car is an integrated system, and that system, as a whole, failed completely. The material clearly shows an immediate, catastrophic cascade of failures. And it wasn't centered on the chassis. It was centered on the logistics of making the engine actually run.
Right.
We saw the immediate issues with fluid dynamics. The 30-year-old gasoline was basically varnish, the oil was solidified sludge, and the critical fuel line was cracked. That crack led to the fuel siphoning back into the tank, making a startup completely impossible until that line was physically replaced.
Okay, but replacing rubber and draining fluids, that's standard simple maintenance after such extreme neglect.
See, I disagree that it was simple or standard. The systemic fragility extended much deeper into high-precision mechanics, which is really the heart of my argument regarding obsolescence. The critical, debilitating failure was the rich mixture in the idle problem, and it all stemmed from the twin SU carburetors. Now, this wasn't something solvable with a screwdriver and a modern scan tool. This was mechanical wear in the crucial internal components, the alt-ust meme, which is the precision-fit needle and piston assembly that regulates fuel flow in response to vacuum.
But that's just a worn part. Any car has worn parts.
Is it, though? It's rare out apart with extremely tight tolerances that is absolutely essential to the carburetor's nuanced vacuum operation. And because this is, for all intents and purposes, antique technology, the general mechanics, like any Susta, they just couldn't diagnose it. They couldn't resolve it. They had to call in the old soil expertise, Mustafa Usta, a specialized carburetor master. He's one of the few individuals left who can still understand and address the specific wear patterns in those high-precision systems. It's a skill the modern world of fuel injection has made almost totally irrelevant.
And he fixed it, which proves that the vehicle is entirely serviceable. You just need the right expertise.
But the dependence on that rare, specific, and culturally disappearing knowledge is the very definition of functional obsolescence. The repairs weren't simple. They involved setting the ignition platinum gap. That's the distance between the contact breaker points, which defines the timing, precisely to 0.40 millimeters. This level of fine physical adjustment requiring a high degree of specialist feel. That's what the complexity of the vehicle demands. The undeniable quality of the metal shell is meaningless if the complex systems necessary to actually move it are functionally dependent on knowledge that is just no longer being taught.
Okay, let's transition directly into that core debate then. The durability of material versus the inherent reliability of the system logic after that 30-year test. You highlight complexity as a flaw, but I see evidence of robust engineering choices that were designed for deep maintenance longevity, even if they complicate a modern repair job.
I am just not convinced that the systems demonstrated exceptional reliability over the long term. They didn't. The failure was absolutely systemic, not structural. If the design was truly superior for long-term functional viability, then why are there design choices that actively complicate modern maintenance? You brought up the magnetic oil drain plug. Okay, yes, it was intended to collect metal shards, but it was doing exactly that, which proves internal wear was happening constantly over the car's operational life. And what's more, they needed a non-standard, massive 25mm socket just to remove that plug. That's a feature of idiosyncratic, specialized maintenance, not universal durability. The vehicle could withstand 30 years of physical stasis, but its operational systems proved they did not survive intact.
That's a compelling point about the complexity. I'll grant you that. Though I would frame it differently. The components that did survive show an exceptional commitment to quality that resisted systemic failure. I mean, consider the original oil filter, still in place, or the transmission oil that came out surprisingly clean. So clean, in fact, the mechanics called it choky-y, very good, despite 3 decades sitting in the sump. The failure of the fuel hose and the platinum ignition points, that's just expected wear after 30 years of pressure and environmental exposure. The structure's ability to resist decay in a damp garage is the true anomaly here, not the system's simple need for consumables to be replaced. The design logic wasn't to prevent wear entirely, but to ensure that wear and static exposure did not cause a wholesale structural collapse.
But the core difficulty remains the inherent complexity and fragility of the high-precision parts, the very parts necessary for motion. The critical failure of the SU carburetor's piston and needle was due to mechanical wear combined with environmental degradation. And that demands a level of sensitivity and understanding that the modern automotive world is just replaced with computer modules. This highlights that the complex logic of the ignition, the platinum system, and the fueling systems are functionally outdated. The restorers were also confronted with a kind of cultural obsolescence. They had to decide between keeping the original standard blue or green inorganic antifreeze or modernizing to a ready-mixed organic fluid. The very fact that this specific, nuanced, preventative knowledge is disappearing makes the car harder and harder to keep alive year after year.
Well, that brings us directly to the question of compromise and modernization. I would argue that the attempt to maintain and respect the vehicle's originality is what defines its value proposition and what justifies the effort in the first place. We saw the team make every effort to use high-quality replacement parts that respect OEM standards, a quality MAN W917 oil filter, the correct 80W90 gear oil for the transmission. The focus was on fixing what existed to the highest possible standard, not fundamentally reinventing the machine.
I'm just not convinced by that line of reasoning, because the authenticity was immediately compromised out of sheer functional necessity. And that proves that the original quality had inherent limitations. They had to use synthetic modern fluids, specifically 10W40 engine oil and ready-mix antifreeze. They replaced key ignition parts, the burned platen, adjusting the Turnock RLAU, the spark plug gap on the plugs to modern standardized measurements, all because the original systems failed or were simply too compromised to be reliable. And what's more, even the initial startup was forced. The team used that old technique of forcing compressed air into the gas tank to repressurize the fuel line. That shows a reliance on specialized non-standard methods rather than pure mechanical integrity. They basically had to cheat the system back to life.
To call that a cheat is, I think, a bit harsh. It was an experienced technique used to overcome 3 decades of dormancy. But the commitment to authenticity did yield fruit, and it shows where the true enduring value really lay. They discovered hidden original parts, like the missing original signal light lens, proving that the underlying integrity was worth digging for. And most critically, look at the contrast in quality. The original unrusted body metal stood in stark opposition to the severely rusted, non-original aftermarket welding done near the seat rails in the bagage havuzu, the trunk well area. The quality difference is just so evident. The factory-built structure resisted decay. The later, non-original fix completely failed.
That is a powerful distinction, and I agree. The longevity premium of the factory metal is clear. But let's use that insight about the aftermarket compromises to discuss the larger context. The design philosophy that separates this car from the modern paradigm. Your position, which celebrates this extreme durability, it relies on a manufacturing philosophy that, well, frankly, it just no longer exists.
I can see why you'd think that.
Modern manufacturers explicitly design cars to be iscarta, to be scrapped after 10 to 15 years, maybe 150 or 200,000 kilometers. Operating this Volvo requires a constant cultural resistance against that modern norm of planned obsolescence. I mean, just consider the current discussion about automatic transmissions. Their cost of revision is so high today precisely because users neglect necessary oil changes. That's a problem rooted in a culture that expects cars to fail and believes modern systems are sealed for life. The Volvo represents the absolute antithesis of that culture, and that very resistance creates a huge complexity for the owner.
I will concede the point entirely regarding the manufacturing philosophy, but the Volvo's value is precisely because it explicitly rejects planned obsolescence, and that makes it a rare artifact. The evidence of its survival is everywhere, even in the sludge. The fact that the engine block required such intensive cleaning using motor champagne and engine shampoo twice to clear decades of baked-on sludge and residue, that's not a sign of failure. It is, rather, evidence of its extraordinary ability to survive decades of neglect and abuse that would utterly destroy a modern, highly tuned vehicle with tight tolerances. It cleans up and it runs again because it was over-engineered for physical survival.
It survived the intensive bath, yes, but only thanks to rare, expensive expertise and the forced replacement of its specialized original systems. The very fact that the intensive cleaning was necessary illustrates the enormous functional gap between its structural resilience and its systemic viability after 30 years.
The successful restoration, in the end, proves that deep durability provides a measurable intrinsic quality that absolutely surpasses the short-term maintenance hurdles, however high they might seem. The vehicle is now running like a clock after specialized care, and that's a testament to quality engineering that defied 3 decades of decay. That demonstrable longevity is, for me, the ultimate measure of its enduring value.
And I have to disagree that the intrinsic quality surpasses the functional hurdles. The entire experience demonstrates that high-quality components alone are just insufficient for long-term functional value. The inherent complexity and fragility of specific, dated systems like the delicate platinum ignition system, or the SU carburetor's really nuanced vacuum mechanisms, they pose a severe, ongoing, long-term functional risk. Such vehicles remain totally dependent on rare, expensive expertise and necessary, permanent modernization compromises. Functional viability is not guaranteed just because you have a strong chassis.
I think we both agree that this specific vehicle demanded the absolute highest level of specialized craftsmanship to return to operation, from the master locksmith to Mustafa Usta. It's clear that the relationship between material quality and functional reliability is deeply complex, especially when you measure it over such extreme periods of non-use.
Indeed, the longevity of the Volvo shell is remarkable, but the immense effort required to make it actually run, that illuminates the hidden costs of complexity and systemic obsolescence that you really have to weigh against that durability.
And so we leave the listener to weigh whether the triumph of structural resilience outweighs the profound burden of systemic fragility in calculating the lasting value of this exceptional machine.